Okay, so now we have an interesting twist on the problem. In this part B here, the balls are distinguishable, but the boxes are indistinguishable. Okay, so just to be clear, what that means is, since the boxes are indistinguishable, that is the same as that, which is the same as that. Okay, so this is a slightly more challenging problem. The balls are distinguishable, but the boxes are not distinguishable.
Well, I see a way you could approach this.
Oh, okay. Yeah, what do you think?
You could just do it like before. You could have three choices.
Okay.
And then you have to account for the ways you can move all of these around.
Oh, that's a very good way to think about it. You can pretend like it's the same as before, and then you can account for all the symmetries. So, for example, if there was just one ball, there'd be 1, 2,
Maybe 3.
3 ways. And then how many symmetries are there here? What can we do?
Well, we have. I guess you can put. First one here, you can flip these around. These are different. You can flip these around. These are different. You can flip these around.
Okay.
So that's six different cases.
Uh-oh. Well, we only had 3 different cases to begin with.
So.
Well, you can think about what you're doing. You have to choose one of these 3 boxes where this ball can go.
Okay.
Which is going to be 3 choose 1.
All right.
So there are going to be, again, 3 different cases. But the symmetries, there's only actually 3 symmetries. Because all you're doing is choosing to put the ball here, here, or here.
Okay. So you're right. If all the glasses were distinguishable, there'd be 6 different ways to rearrange them. But here with just 1 cube, there's only 3 possibilities.
Yeah.
Right. So if there's only 1 cube, and the boxes are indistinguishable, how many ways are there to put that 1 cube into the boxes?
There's only 1.
There's only 1 way to do it. But we have a more complicated problem here with 4.
So I've got a way to look at this.
Okay. What do you think?
So I'm going to divide this up into cases. So, like, the ways, I'm going to pretend the balls are all the same, and just ignore them for the moment.
Okay.
So the first case is all 4 balls are in 1 box.
Okay. So how many ways are there to do that?
There's just 1 way to do that.
It's just 1 way to do that. Okay. Hopefully this pen works. All right. 1 way, all 4 of them go into 1 box.
Yeah.
Okay.
The next case is going to be 3 and 1.
Ooh, 3 and 1. Okay. This might be a little bit more complicated.
So, in this case, what you're choosing, so you're choosing 1 cube not to be part of the big group,
All right.
and it doesn't matter where it goes because it's just the same case.
Okay.
So it's just 4 choose 1, just 4.
All right.
So there are 4 different ways to have this 3 in 1 case.
Ooh, wow, just 4. So I thought this was going to be really complicated, but you're telling me there's only 4 ways to do it. Can you explain why there's only 4 ways?
Well, it doesn't matter, like, how we rearrange these because they're indistinguishable cases. So you just have to account just this one.
All right. What do you have to account for here?
So you have to account for all the other balls that are gonna go in the 1 slot.
Okay. And how many different ways can you pick that 1 ball?
4.
4. Okay. Cool. All right. So now we're off to the races here.
And
I guess you can pick.
yeah,
2
the
and 2.
2 and 2 case.
Okay.
Now here, what you're doing is you're choosing 2 cubes to not be part of the cluster.
Uh-huh.
And the other 2 slots just fill in themselves.
All right.
So this is 4 choose 2, which is 6.
Okay.
6 ways to do this.
All right. All right. Let's take a look at this. Because I'm not sure if this is 6 or not.
So you have to choose to divide 4 things into 2 groups of 2.
Okay.
So you could like if you start with the first ball here, you could have 4 different positions.
Okay.
And the next one, you could have 3 different positions.
All right.
And the next one, you could have 2 different positions.
Uh-huh.
Last one's is fixed.
Okay. So that's 24.
24.
Okay. So what's happening in that situation?
Well, you've got a bit of overcounting because these are indistinguishable.
Okay. You've got some overcounting because those are indistinguishable.
So, like, that's the same.
Aha.
So you have to divide by 2.
Okay. Well, now you're at 12. But you said 6. Yeah.
Well, you can also, it matters the order in which you choose them.
All right.
Because you could choose this one and then that one.
All right.
That's actually the same, and you can flip them.
Yeah, then you can use this one first and then that one.
Okay.
So you actually, then you have to divide by 2 again
All right. So now you're at 6.
to get 6.
Okay. Is that your answer?
Well, no, not yet. Not.
Okay. What's wrong with 6?
Well, you also have to divide by 2 again because of this one.
Of that one. So we're down to 3.
There's only 3 here.
So we better check and make sure we understand this, okay?
Okay.